Hello everybody. In this video we will train a simple and basic neural network to classify the species type using Iris dataset. So this dataset I have downloaded from Kaggle, so you can download these as well. I will have both the CSV file for this dataset and this Jupyter notebook on my GitHub page, so you can work and practice on it. Again, this is going to be a simple neural network. All right, so let's begin importing some of the packages. Let's import pandas, which is going to be our data analysis package, and then let's import numpy, which is going to help us to build and manipulate arrays, and let's import seaborn, which we will use it at the end to visualize the data sets. And then let's import from TensorFlow, import Keras. Let's import Keras, which is gonna be we will be using to build and train our model. So let's import everything. So I'm using, by the way, a Jupyter notebook, and you can use Google Colab, which would be a lot better actually. So let's look at our data frame. Let's create a data frame called df. We'll be using pandas because we imported pandas as PD. So let's add this read CSV functions, and here you gotta provide the path for the CSV file. So in this case, my file is in the same folder as this notebook is. So you can see here my Iris dataset CSV is in the same folder. If it's not, you can provide the direct path link to that CSV file. Okay, so let's read it out. So this head function will give you first 5 rows. Okay, so you can read more. Like if you want to read only first 4 rows, you can provide 4 by default. Like if you don't specify anything, it will read first 5 rows right here. So I can see here, so we have few columns here. This ID column, this is basically index. So 0th index is ID number 1, first index is ID number 2. So these are just roll number. We can delete this column. This does not add any values. Then we have sepal length, sepal width, petal length, and petal width. So these are the characteristics of the flower. And then we have the type of species. So let's see how many species we have. So I can see one of them is Iris-setosa. So you can find out how many different type of species we have in this data sets by something called data frame. You can access the column by square bracket and inverted comma, and then let's do value counts. So value counts would tell us how many types of species we have. So we got Iris-setosa, which is the first one, versicolor and virginica. Each one of them we have 50. So this is not a huge data sets, but we will have to use whatever we got to train our neural networks. So let's do a quick check. Dataframe.info. That's gonna tells us the data types and how many we got. So we got 150 entries, and out of those 150 entries, 150 are non-null values. So this means there is no null values, which is good. This data set is already cleaned out. We don't need to do any cleanup. And you can say the data type here. For example, here you can see IDs are int 64 types. So IDs are int 64. Obviously, these are integers. But the species are object type. So species is here. So first thing we have to do is convert this species name into some sort of label. Okay. Another thing you can use to check if you have any null values is by this data frame is null. Is null is gonna give us a true false. So you see, is the first row, first column, is it null? The answer is false. And you can go back, check here, the first row, first column, it doesn't have a null value, so it's false. But obviously you cannot go through everything. So there is one shortcut. You can just sum it up and you'll find out every column, the sum of all the Boolean values is 0. So if we have any null values, the answer would be 1 or higher number, depending upon how many null values we have. So everything is 0. So this data is clean and ready to go. So let's do few things. Let's convert this species name into label. So we can do that by using scikit-learns. So let's do from scikit-learns dot preprocessing. Let's import label encoder, and let's do that. So le dot le equals to label encoder. So let's create an instant, and we do fit transform, le dot fit transforms, and then we're gonna be using our data frame, and we're gonna be using our species columns, right? So it's gonna fit and transform the species columns. Okay, so you can see now. So let's look at the data frame dot head. So le data frame fit transforms data frame species. Oh, sorry, my bad. Data frame dot species. I forgot to, oh, I forgot to change. Okay, so let's change the species column into this new fit transform, and let's look at again. Okay, so you see now all the species are labeled as 0, 1, and 2 because we have only 3, right? So you can look at the type of classes. So le dot classes tells us, it's gonna give us a list what's in there. So the first one, it's gonna give us a list. The first one is Iris-setosa, which is where all of these numbers are 0. And then you see have Iris-versicolor, Iris-virginica. It goes by alphabetical. Like when it's labeled by alphabetical. So this is 0, this is 1, and this is 2. Okay, you can see. So let's make this species name. I just put this as a list so that we can use it later when we once we finished training our model, we will use this label. So you can see here, this is our species name, that's the list. Okay, so let's split our data into X and Y. So X is gonna be data frame dot drop and columns. So what I'm doing here is our X variable is gonna be these. So sepal length, width, petal length, and petal width. So these 4 are gonna be our X, and the Y would be species label, and we're gonna get rid of our ID. So in order to find our X, we're gonna drop these 2 columns from this data frame. We're gonna drop our ID, and we're gonna drop our species. So let's provide columns equals to, so you have to provide a list of columns. So first one is ID, next one is species. Okay, so we have our X, and then our Y would be data frame, the species names. Okay, so you can check again X dot head first 3. See, our X is now only sepal length, width, petal length, and petal width. That's our X. And you can check Y, print Y, and let's print first 5. And you can see first 5s are 0, 0, 0. All right. Okay, so that's pretty good to go. So we have X and Y. So let's split our data sets into 2 groups. Training set and testing sets, right? So we will be using the training set to train our model, and then we'll be using our testing set to test our model. All right, so let's bring, and we can use this from scikit-learns, from sklearn.model selections. We can use trend test split, and in order to split, you have to provide the name. So we're gonna have xtrain, xtest, ytrain, ytest, and this one gonna be our trend test split, and we're gonna be splitting our X, splitting our Y, and our test size is gonna be let's say 30% of our data is going to be our test size, and let's shuffle our data to make sure we get good distributions. And random state is 69. You don't have to provide random state. It's just if you are trying to optimize your model, so it's good to have a random state so that you can find the best parameters. Okay, so we got that, and let's run it up. Okay, so a few things we can check. xtrain.shape. If you check, it's 1 of 5, 4. So we got 1 of 5 rows and 4 columns, which is basically stands for these 4. Okay, so one thing you notice here, the numbers are pretty much same, but it's slightly different. So it's 5.1, 3.5, 1.4, 0.2. So in order to sum up these variables get over optimized, what we had to do is we gotta scale our data sets, and we can do that by sklearn preprocessings by a standard scaler. So let's scale all of our data. Let's create an instance, sc equals to standard scaler. So this is object-oriented programming, by the way. So let's scale our data set xtrain. Xtrain equals to sc.fit and transform. And what we are transferring xtrain. And also we should do that for testing set as well. But this time I'm not using fit. I'm just using transform because it's already fit. Otherwise you're gonna have huge error. Okay, so we have our X test as well. So we are transform. So you can do before and after if you want. Let's look at print before and after. So print xtrain, and we're gonna print the first rows, right? So print xtrain before, and also we're gonna print xtrain the first row after. Okay, so this looks good, and you see the 57th index, the first row was 4.9, 2.4, 3.3, and after scale down, the new version is it's going to give you a 2-dimensional numpy arrays. It's negative 1.14, negative 1.4. So so just can scale all the data sets into reasonable range. All right, so that's how it looks. Now we're gonna do our training. Oh, one last thing we're gonna convert the Y. So here it is 0, 1, 2, all those values are. So we're gonna create a binary matrix. So we're gonna tokenize those, and we can do that. I'm just tokenizing the training data sets. Keras has this functions called toCategorical. So what this will do is it will take 1-dimensional arrays, convert into a 2-dimensional binary matrix. So ytrain, and num classes, we got 3 types of data, and you can see right now how it looks. Print ytrain, so let's print first 5. Okay, so you see here, so the ytrain, it's now we got a 2-dimensional arrays where the first column represent our index 0, which is here Iris-setosa, and second column, so if there is 1, that means the data set is saying that it is actually Iris-versicolor, and so on. So it's converted into 1-dimensional arrays into 2-dimensional arrays, 1-dimensional list into 2-dimensional arrays. That's the one way to look at it. All right, so now we are ready. I think all of our data are pre-processed, And let's build our model. So from Keras, we're going to be using Keras from TensorFlow. So we have already imported Keras. So from keras.models, let's import, we'll be building a simple sequential model. And let's import some layers, keras.layers. Let's import, so we'll be using a simple dense layers, and then we're gonna have dropout, and I think those two would be more than enough. So let's create a model. So our model is sequentials, and let's build our layers. So our first layer would be input layer. So model dot add, it's gonna be a dense layers, and let's just put 32 units in here. And then our activation function is gonna be ReLU, and our input shape is gonna be if you look at the shape, the training data sets has 105 data sets, but it has 4 variables. So that's the one it's gonna be your input shape. Again, instead of writing 4, you can be a little bit more creative. So you can say xtrain dot shape, and it's gonna be the last index. So xtrain dot shape is one of 5 and 4, and the last one is 4. So -1 means last ones. Okay, so this is gonna be our input. Then let's have one hidden layer, and have, again, let's just put 32. And this is gonna be a very simple and basic, so you can play around with it. So this is already connected, so we don't need to add shape again. And let's add a dropout layer. So dropout would help us not overfitting. Let's say 40% of the data, maybe 50 if you want. 50% of the data will randomly drop, so that will stop overfitting. And let's have one output layer. I think this is, since this is a small data sets, by having only one hidden layer would be more than enough. So it's again going to be a dense layer. This time our unit's going to be 3, because our output could one of these 3 column, right? It could be first one, second one, or third one. And our activation function is going to be softmax. Okay, that's gonna be our output layers. So we are good, looking good. And let's compile all the model. Model.compile. And we're gonna have to provide our optimizer functions, which is gonna be Atom. And then we have to provide our loss functions. That's gonna be categorical cross entropy, because we have 3 categories, right? If we had only 2 categories, then we could have used binary cross entropy. When you have multiple of them, you use categorical cross entropy. And your output cannot be more than 1 categories, right? So that's when you use the categorical cross entropy. If your output could be in 2 categories, like it could be this one and this one, then you cannot use that one. All right, so and then we have to provide matrix. Matrix would be our accuracy. We'll train based on the accuracy score. Let's summarize our model. Model.summary. Okay, so you can see here, our summary is telling we have not a lot of parameters, only 1315 parameters, and we are good to go. So at this point, all we have to do is train our model. So in order to train our model, we use model.fit functions. And we're going to provide our training data set, which is xtrain. And then we're going to provide our ytrain data sets. And then how many epochs. I'm not using batch sizes here because it is already a very small number of data sets, 105. So it's going to be easy to do. My computer and your computer can easy to handle. And epochs, how many times you're gonna pass through your entire data sets. Because it's a small data set, I'm just putting it will take a lot more time to train. So if we pass 100 times, that might be able to do it. And then we will do next thing is verbose equals to 2, which was just let us show. I'm not adding validation data sets here because our data sets is already small and we don't want to lose any more data. Okay, that looks pretty good, and let's train. And it's gonna be very fast. So we started here, our accuracy score was 0.38, but over time it's improved pretty good, 96 at the end of our 100 out of 100 epochs. We might have overfit, but our dropout rate is pretty high too. Okay, so that's good. Let's do predictions. So predictions is gonna be model.predict, and we're gonna be using our X-test dataset. And let's print predictions, and let's print the first 5. Now you see, when you do this, you're gonna get a bunch of this 2-dimensional arrays here. Like, how the hell are we gonna figure out what our output is? So it's giving the softmax number for each possible species. So if you look at the first row, so this is the first predictions for our first X-test data sets, right? So it says 9.9 times 10 to the power negative 1. This is 4.8 into 10 to the power negative 4. And this is 5.3 into 10 to the power negative 5. So how can we convert this? Which one is our best guess? Our best guess is whichever is the bigger number. So in this case, this seems like the largest number. So we can find that out very easily by using a NumPy function. So let's create predictions equals to np.argmax. It's going to give the index of the maximum locations. So we're going to be applying on the same predictions, the one we just did. It's just going to give us the argmax locations. So for this row, our argmax output would be 0. However, for next one, the max number is the middle one, so output would be 1. So you can see here, predictions, and then axis. So we want to find out on our last axis. Last axis is always the column. Okay, now that's good. Predictions is good to go. Let's print it out. Print predictions. And let's print it out the first 5. And you see the output is 0 because the index number is 0. So 0th column has the highest value. Output is 1 because the index 1 has the highest, column index 1 has the highest value. So this is column index 0, column index 1, column index 2. On the 4th one here, the highest value is on the column index 2. That's why the output is 2. Okay. Let's compare against our y-test. Y-test, again, first 5. It looks pretty good. 0, 1, 0, 2, 0, 0, 1, 0, 2, 0. So it's perfectly matches. So instead of just reading it out, let's use the math to do this. So let's print our accuracy score. So we can do that from scikit-learns, from sklearns. Let's import accuracy score from sklearn.matrix. Import accuracy scores and confusion matrix. And let's print our accuracy score. So when you print it out, you gotta provide your original data set, which is y-test, and your predictions, which is your guess. Okay, we got 97%. I like to see a confusion matrix in this scenario, so let's do that. Confusion matrix, again, you have to provide your original y-test and then your guess, or the model's guess predictions. And let's just print our confusion matrix. All right, so yeah, 16, 12, 16, and we have only one mistake the model did. So let's make this look a little bit prettier using our seaborn. So I'm gonna do heat map, and we're gonna be using our confusion matrix annotations. Let's make it our annotations, and let's do format. It's gonna be let's color map. Again, you can use anything. So I'm using red. Xtick label. So let's just print this one. Okay, so we got this. This looks pretty nice. The label Xtick labels are 0, 1, 2. So remember what's 0, 1, 2 were? If we go back here, our 0, 1, 2 were here. 0 is setosa, 1 is versicolor, virginica. So that's our species name. So let's replace this 0, 1, 2 with the species name. Okay, so Xtick labels are species name, and y-tick label is also species name. And there we go. So we have the labels are ready to go. So let's add axis title. So let's add a title for this graph. So ax equals to ax.setTitle. And title is confusion matrix for Iris dataset prediction. Okay, this is a long title, but worth it. All right, let's add axis title as well. So ax.setXlabel. That's gonna be your, so x-axis is this one. This is predictions. So this is what predicted, and this is the y-axis is actual. So that's your predictions. Let's make it a little bit bigger font. So font size is gonna be 14, and ax.set y label, and y label is actual, and the font size, make it bigger too, is equals to 14. All right, so if you notice, this is our predictions. So we predicted 16 times to be Iris-setosa. It turns out to be Iris-setosa all the 16 times. However, if you look at here, we predicted 12 times that sample is going to be Iris-versicolor. So it was versicolor, but one time we predicted as versicolor, but it turns out to be virginica. Okay. So this is our actual axis. This is our prediction axis. All right. So this is how you train, you build a simple, we should not call it deep learning because there is only one hidden layer. To be called as deep learning, you need more than one. So this is, I guess you can call it simple machine learning, simple shallow learning. All right, stay tuned for more such videos, more such tutorials.